Welcome to Hidden Layers, where we explore the people and technology behind artificial intelligence. I'm your host, Ron Green. So here's the puzzle. Large language models can explain medical exams, string theory, and even debug your code. But ask them a simple fact like somebody's birthday, and they'll just make something up. Not tentatively, not with caveats, but with total confidence. Why does that happen? Researchers call it hallucination, and it's one of the most interesting unsolved problems in AI right now. Some groups are trying to catch hallucinations in real time, almost like putting a fact checker inside the model. Others are asking deeper questions, like maybe the way we train and score these systems actually pushes them to bluff rather than admit when they don't know. If that's true, then hallucination isn't a bug at all. It's what we've accidentally optimized them to do. To make sense of all this, from the technical fixes to the deeper incentives, I'm joined by two of the sharpest minds in the industry, my co-founder and distinguished machine learning engineer, Zizi Tsai, and our vice president of engineering, Michael Wharton. All right, guys, ready to talk about hallucinations?
Yay.
Oh, yeah.
Okay.
Waiting for it.
So first off, hallucinations are obviously still a big problem, but I feel like I'm definitely seeing them less now than even 6 months ago. How about you?
What do you think, ZZ?
Yeah, and I definitely feel like the language models are getting better. And the early kind of simple errors like counting R's in strawberry and other similar tests are now passing with the frontier models. So definitely, I feel that's true. What about you, Michael?
Yeah, I think that's the case. And even still, I feel like there are ways to use them now, especially for personal productivity tasks, where you can pretty quickly identify if there's something that's a problem because, I mean, I'm just in the habit now. I use Claude most of the time. And at the end of every prompt, I'll just be like, please search to validate your response. And I'll go check. Yep. And the fact that they can do tool calling and go validate with searches and
exactly.
See, all right, but I almost feel like that's cheating a little bit.
It is cheating.
Right? Like,
it is. Yeah.
Like,
but it's the dominant use case that I have.
I completely understand. So I'm probably I use Claude for coding, and I probably use ChatGPT 5 mostly for personal stuff. And I've found that, well, a couple things. One is, this is strange, but I've felt over the last couple of years, I've gotten good at almost detecting hallucinations.
Mm-hmm.
Do you feel that way too?
Yeah.
Like when it says something, and I'll feel like that can't be right, and I'll check. And the reason I feel like hallucinations are down is increasingly when I think the model's wrong about something, mostly factual, it'll come back and go, no, I double-checked, that was correct. So definitely getting better at that. But then the other area is that there's just a difference between sort of work hallucinations and personal, request hallucinations. And most of the time, you guys are using, if you're using Anthropic's Claude model, you're using it for coding, I would imagine, most of the time.
Most of the time, yeah.
Zizi, what percentage code do you think you are writing these days?
I use it every day, and I feel like I am already used to hallucination. It still happens every day.
Yeah.
But I think we're just trained to deal with it and expect that will happen.
Yeah.
So an example is I'm sure if you use one of the coding agents, and this is not particular to any providers. Like I think Claude Code has the problem, Codex has the problem, which is the GPT one. Gemini also have similar problems. So you will hear, you are absolutely right. And then it will say, okay, here is what I changed. With my change, you're going to get this, this, and this, and passing 100% of the tests.
Yeah.
You're going to get this functionality working 100%. And I was like, no, it's not. Because I checked and, I will run the code and it's far from working.
Yeah.
So that definitely happens.
And you can get in that death loop too, where you're consistently asking, like, oh, no, that's wrong, try again. No, that's wrong, try again.
Exactly.
And then it's almost, I've gotten to that loop before, it'll happen like 5 times. And it's like at some point, it's better to just scrap it and start over with a better prompt.
Yeah, exactly.
My worst, hallucination cycle I've been in recently, this is like in the last couple of months, was I was working on a presentation and I was kind of wordsmithing it, and this was with ChatGPT, and it said, would you like me to create some images for that? And I'm like, well, I didn't really want them, but I was like, sure, yeah, I'll take a look. And all the images it generated with the links were broken. And it was like, do you want a slide? I was like, well, yeah, create a slide. Got done, the links were broken. Like, it was just making up fake links. Had done none of the actual work.
Yeah, I love it.
Yeah. So, okay. So we're making progress on this front, but I genuinely believe Hallucinations is one of the most interesting and most important unsolved problems. I'm going to come back. I've asked some questions about whether you think, I'm going to ask you guys later whether you think we can ever solve this problem entirely. Well, Michael, you read a paper you're going to talk to us about called Why Language Models Hallucinate. This is a new paper from OpenAI, just came out this month. I took a look at it. It's really, really interesting. Can you take us through it?
Yeah, absolutely. So, yeah, I mean, at the end of the day, it's not, there's some dense parts of the paper that get into some pretty rigorous math and stuff. But at the end of the day, it's really not that complicated in terms of outcomes. There are two really key points. One is that, for, I guess, years at this point, we've been just throwing around that claim, hallucinations are inevitable. They added some mathematical rigor behind that claim that I think is just useful to know about, to just verify that this is going to be a persistent problem that we'll have to deal with. And then they also made some recommendations on how we do evaluations. Very practical, and I would argue kind of like obvious in hindsight, but I'll go through that in a second. Mm-hmm. So in terms of the sort of inevitability of these hallucinations, it's actually kind of a hard problem because when you define what's correct, what's hallucinated, what's not, there are these degenerate cases that are still technically correct, but that you kind of muddy the waters in terms of the analysis. Like if you were to create a simple computer program that just said, I don't know, to every single prompt, theoretically that's a correct or at least like a valid response.
No hallucination. Yeah.
There's no hallucination there, but it's also total garbage in terms of utility.
Right.
And the same thing, if you just memorize your training corpus complete wholesale, you're not really learning any underlying distribution, but I guess it's correct. But what they did was they made the observation that you can frame any language model as a binary classifier in terms of just, is it valid? Like you supply a prompt, you get an answer, and you ask, is it valid? That's a binary classification problem. And there's a benefit in terms of just decades of research and statistics and learning theory that helps us make a lot of big claims as long as it's a binary classification problem. There's a bunch of math underlying there, and really the claim here is that those types of errors that you would have with binary classification are a subset of that broader group that include hallucinations. And those we can mathematically guarantee under reasonable assumptions that you have with language models today. Does that generally track?
Unpack that a little bit more.
Yeah. So some of those assumptions are things like you're using cross entropy to train it and that it's reasonably calibrated, which notably, that's a really crazy assumption with some of these post-trained models because we know they're famously poorly calibrated.
Right.
But their analysis was pretty focused on pre-trained models, which are generally pretty well calibrated.
Right.
But yeah, so a lot of those assumptions were, pretty important to at least include. And then if you just assume that, actually, an interesting part is that even if your training data set is completely error-free, which you would imagine to be a pretty key contributor to hallucinations and errors.
Yeah.
Assume that those are not even the case. These types of hallucinations are still guaranteed.
Mm-hmm. That to me was one of the most interesting parts about the paper.
Yeah, just because of the nature of how binary classifiers work.
Right, exactly. Yeah. So all right, so let's go another level. There were some of the things in the paper that really blew my mind that I agree with you. They kind of felt obvious in hindsight. This idea that models are being graded, judged. Their loss function is trying to determine how accurate they are in their output, right? In their ability to predict the next token, which essentially does not reward you in any way for admitting you don't know. Because even if you have a 1 in 100 chance just by guessing, that's better than a 0% chance of saying you don't know. So one of the things that the paper, I think, again, seems pretty obvious, is there needs to be a modification to the way we train the models so that the loss function can separate guessing and not encourage guessing, right? And one of the examples they give is essentially penalizing models based upon the basically the inverse of their confidence level in the tokens they're generating, which seems, I think, at a high level, seems pretty straightforward to me. The other part of this is that, there's always going to be a problem with hallucination when you're dealing with sort of rare information, information that was maybe only, the example they give is like somebody's birthday that appears in the corpus maybe once, right? Or maybe not even at all, how you handle those situations. And then, of course, that dovetails with the whole theory around how much or the whole thought that hallucination is not necessarily a bad thing because it's sort of tied in with imagination and creativity, and that you want to have those components. I'm less sold on that, but it's an interesting thought experiment as well.
Mm-hmm. Yeah, especially that. I mean, I think that the evaluation piece, really to just kind of hammer that home. The thing that, again, is just obvious in hindsight is like most of these really rigorous benchmarks are multiple choice.
Right.
Like even the medical benchmarks, the software coding benchmarks in a lot of cases are multiple choice. And if we're just rewarding confident guessing, like it's no wonder that these models are really poorly calibrated. So if you penalize them for answering a question and getting it wrong, but you reward for getting it right, then that makes no claims about how we're supposed to make these models better,
right?
But it does at least align the evaluations more with the behavior that we're trying to elicit, which seems, great. Honestly, who wouldn't want that?
Right. And I think it's also a reason that we're seeing coding and math performance with these models lead the way because they're verifiable.
Yep.
Right. You're training with verifiable domains. And I think it's easiest to drive out the hallucinations and achieve human or superhuman abilities.
Yeah. 100%.
Yeah. I'm curious whether the paper mentions using more of a reinforcement learning as a way to reduce hallucination.
Yeah, they did talk about, I guess they made no claims on exactly what sort of algorithm, but they did talk about the changes that happen between when you have a pre-trained model and then you use reinforcement learning to post-train it. I don't think that they dug into that as much as they probably should. But they did imply that there's like a host of techniques and it's relatively underexplored to try to minimize these hallucinations with algorithmic tricks and techniques. But the thing that I don't know about how you guys feel about this, I don't care if we get rid of them completely. I think if we can just get them to the point where the models have utility, it's almost like, I think about it kind of like medicine, where the goal is not to just remove all error. That's kind of ridiculous, but you can imagine you'll cross this threshold where the error rate is below a specialist or like a human level, and then at that point it's just negligence not to use it.
Right.
Yeah, who cares if we can get rid of these things completely? Let's just suppress them as much as we can and move on.
I genuinely don't think it will be possible to get it to zero anyway, because I don't care how good these AI systems get. Even if we have artificial superintelligence, they're not going to be omniscient. They're not going to know everything. They're not going to be error free, right? I genuinely think that that is sort of a false error, and there's no way to achieve systems like that, no matter how sophisticated they get. It's just a part of the universe we live in my opinion.
Yeah, I totally agree. I also think that it seems to be inherent. The hallucination seems to be inherent due to the way it's trained. Because, let's consider the pre-training and not to think too much about our RL yet. So I feel like in the LLM world, there's no notion of reality versus not reality. The whole world to the LLM is the web corpus that it has seen, and all it's asked to do is to when we're using it, when we are chatting with it, is to, hey, here's a new document, and this document is a new conversation. Just help fill out what could be the possible words spoken here, based on what you have already seen in the web corpus. And so, there's no notion of reality. There's no notion of grounding. So, we cannot ask the LM to do things that it's not trained for. It's totally different.
That reminds me of that quote. I don't know if it's even been attributed, but that quote that all language model outputs are hallucinations. It's just that some of them turn out to be true.
Yeah.
Right. Yeah.
I
love it.
I totally buy it.
Yeah. Yeah. All right. So now, Zizi, you're going to talk about a paper that kind of goes into the details of maybe not fixing hallucinations, but detecting them, monitoring them in real time, which is really, really interesting. So your paper you're going to talk about is called Real-Time Detection of Hallucinated Entities in Long-Form Content.
Yeah. I think it's a really interesting paper. Of course, as humans, when we use the LLMs, we care about the hallucination. We care about whether it's true according to the reality. So this paper is talking about a method to kind of detect and mark the risk score of the generated text in real time. So before this paper, there have already been a lot of methods to mitigate and detect hallucination, but most of them are post hoc. So after you chat with the LLM, it generates an answer. You can use the LLM or another LLM to independently do a web search or do a retrieval in your internal documents, and then using that as a prompt to compare against the answer from the original LLM. And that's a relatively easy task because once your prompt includes all the information there, then comparing them is a relatively easy task. So you can use that to do the check post hoc. But this paper is interesting in that it can do it in real time. Like it's not a post hoc thing. It's basically treating the problem as a sequence labeling problem. So when the LLM generates token by token, you can use this paper's method to annotate each token with a risk score. And they have a pretty cool demo to show where there's a streaming text generated from the LLM, and then some words will be marked as red, indicating high risk, and some of them are, if it's not highlighted, then it's relatively safe.
Yeah, the demo was super cool.
Mm-hmm. Is it using an external model that was trained for this specific purpose, or is it aware of the weights or? Yeah. Okay, gotcha.
That's a great question. It's not entirely an external model. That's such a great question. I want to dive into the details, and I wanted to discuss and see what you think of the method and how we can apply it to maybe our future clients. First, it collects the data using a kind of the benchmark prompt set. I think it's called long fact.
Yeah.
And they expanded that original long fact prompt set to long fact plus, which has, I think, roughly 20,000 prompts, covering multiple domains like healthcare questions, legal questions, questions about movies, stuff like that.
Yeah.
Mm-hmm.
And then they would collect a training data set by just using LLM to generate the answer, and then they will use LLM as a judge to do a post hoc validation by doing web search. And that process kind of generates this ground truth data, which is not perfect, and I'll talk about this later. So, but still fairly high quality kind of label data set for which spans in a text is hallucinated or not. They actually has 3 labels. I think it's either supported, unsupported, or something like not sure. So that's the output from the LLM as a judge. So that's the kind of the label that you wanted to predict. Now they will train another they will train a model to based on not the output tokens. I think that part is interesting. They're basing on the internal kind of the hidden activation. They picked one of the layers that's later in the network.
Mm-hmm.
I don't think they did a very thorough kind of sweep on which layer to use.
I think they just picked something like 95% into the network.
Right.
Okay.
But yeah, they use that as a feature. It's a token level feature, right? So for each token, it tries to retrieve before that token's output. So it's like, hey, get the thought vector first, and then using that as a signal. And they train 2 types of models. One is called the linear probe. And the linear probe is very simple. It's just that latent feature, hidden feature, and add a linear layer. And then to predict whether it's hallucination or not.
Right.
And then the other method is LoRa, where it's a more complicated way. So basically, they will train this LoRa, and which basically will update the model weights, right?
That's what I thought was really interesting is the linear probe is just trying to learn like a linear
Patterns of
separable
activation.
classifier, but the LoRa probe, they actually were allowing it to modify the weights a little bit to improve the predictability of it. And they said it did not in any way affect the model performance or degrade the model performance.
Right.
Yeah.
Wow.
Yeah.
That sounds almost like or at least the former case sounds like a polygraph or something. Like you're picking up on biometric signals to try to predict if there's a lie or not.
You're putting a probe in the model's brain to try to detect if it is lying or hallucinating.
Yeah. That's crazy.
So the result is super interesting. Yeah, both the linear probe and the LoRa method, I think, outperforms the baseline, like, post hoc kind of validation without web search. Because, if you use the web search, then of course, that's going to be better because that's the teacher.
Right.
But then, the paper's method outperforms all the baseline post hoc way of detecting hallucination, and the LoRa way works better than a linear probe,
which makes sense.
Yeah. It's a more complicated model. It's more accurate. It also changes the model's behavior. It doesn't degrade the quality,
right?
But it changes the behavior subtly. I think you will find this interesting. So after their LoRa training with the same target of predicting hallucination or not, they observed that the model became more cautious.
Great.
Which is really interesting because it's not trained to do that. It's only trained to predict hallucinate or not. But it's not trained on any generation task. But
that was one of my favorite parts of the paper is it would still answer the question, but if it answered it with a hallucination, if it answered it incorrectly, it was more likely to add something like, but this information cannot be verified.
Interesting. So it's almost like adding some layer of awareness to the performance.
Exactly. It's almost like backpropping on that through that LoRa mechanism. That LoRa probe gave it some additional awareness of when it's hallucinating that it could leverage.
That almost sounds like I would put my money on that new model being better calibrated too. Sounds like it would have to be.
It sounds like it would have to be. Yeah, I totally agree with that.
Yeah. That's great.
The only other thing that I think we have to bring up is, as good as it was, it still is nothing that you could put in production. It's nothing that would allow you to use it, I think, in sort of high critical domains like clinical situations where you had the model suggesting dosages or something like that. I believe, if I remember right, the paper said that it could catch about 70% of the hallucinations with a false positive rate of about 10%. Meaning it would classify true statements, non-hallucinations, about 10% as hallucinations. So a lot of work to be done, but it's a really interesting approach. It's the first time I've seen anything like this working, inside the model and not working, once the tokens are fully generated.
Yeah, totally agree. And I very appreciate this paper's approach for mentioning limitation. It explicitly said it's not ready for production. I wish more research papers.
I totally agree with that. I'm glad you mentioned that. That really stuck with me as well. Too many papers come out and they want to hide the dirty laundry, and they did a fantastic job of putting sunlight everywhere, even in the shortcomings.
Yeah. That's great.
All right. I want to ask you guys. On the hallucination front, we talked about this just a little bit earlier, but to kind of wrap up, what is your timeline on hallucinations? Meaning, when do you think, as an industry, we'll get to a point where I think hold on, let me back up. Do we all agree that we think hallucinations are here to stay? I don't know what you think, ZZ. Do you think
I feel like it's here to stay because the model doesn't even know hallucination or not during training.
Right. And Michael, you believe the same?
We can approximately figure it out, but I think at the end of the day, it's an approximation.
I agree too. And and the way I would think about it is the word hallucination to me is maybe problematic. I think about it more like, will we get to a point where the models don't make errors? No.
No.
So if you frame it like that, I think it's kind of easy to say, no, we're not going to achieve a world where models are omniscient and they never make mistakes. Okay, but given that a caveat, what is your prediction? When do you think we'll get to the point where we at least live in a world where the most advanced AIs make mistakes, hallucinate at such a low rate that it's not a topic of discussion anymore? In fact, it might even make the news when it happens.
I have maybe a hot take.
That's a great question.
Please.
I want to hear it.
All right. I mean, I think, assuming we give time for the public to catch up, I think we're kind of already there technologically. Because, I mean, you mentioned that the oracle that was used to train this data set in your paper was just a language model that had access to the internet, had access to some knowledge base of facts.
Right. The ground truth is not perfect. It's actually,
yeah, it's still a problem. It's still there. But I think as humans, we do the same thing. Like we've all but offloaded a huge chunk of our cognition to search engines in the last 10 plus years.
That's a great point.
And people that use Google more often than others are probably less likely to make non-factual claims.
Yes.
I think that if you're willing to hook up an agent or like hook up some sort of tool that has access to that knowledge base, I mean, I think we have the fundamental technological
You could have it
capabilities,
now if you were willing to wait for that sort of post-prediction.
and pay the cost and all
exactly.
that. In terms of your actual question, when we'll get there with language models, I think it's, I don't know, a year or two.
Okay.
I don't think it's too long.
All right, so you're pretty optimistic. ZZ, what do you think?
I don't have a crystal ball, but my bet is maybe longer, and this is informed by my kind of experience with the current coding agents. But of course, they are changing fast too. I feel like it's maybe the complexity of that is of the reducing LLM hallucination to a really, really low level that's negligible is maybe similar to self-driving cars, kind of, our comfort level of using self-driving car on the road.
That's a good comparison, yeah.
There are probably many corner cases, and when we get into deeper domains of either building software or automating internal processes for healthcare, for legal professionals, there's probably a scarce of training data for those. So sometimes even with web search, you still cannot be like 100% sure that there's no hallucination. And this is also mentioned in a paper too. So like the training data is only like, I don't know, 80%, 90% correct.
Right.
So that's why all these kind of expert labeling platforms like Mercor, they're seeing crazy growth and evaluation.
Okay, like if you had to say how many years until you think hallucinations are so uncommon?
Okay,
that they would make the news.
You're really trying to.
I'm going to pin you down, man.
How about 10 years?
10 years?
10 years?
Yeah,
all right.
okay. 10 years.
Okay, that's perfect because I think I'm right in the middle between you. I agree with you, Michael, that I think that if you're willing to wait, we could probably get the right answer to any problem now. But I'm probably a little bit more on the 5-year time horizon before I think the tools that would be baked in to the systems that are used every day and enabled will make hallucinations seem like we'll laugh about 24 or 23 and what we used to see.
Yeah.
Okay.
On the other hand, I do think that LLMs and all these agentic tools can be incredibly useful already without getting to that low hallucination level.
Yeah, absolutely. Yeah, not to take away from the incredible capabilities they have today. Yeah.
Right, especially that we have tools to monitor it and to mitigate the risk.
I think that's a really good point, ZZ. I mean, I don't think that we've learned the extent to which we can effectively use these tools yet. And there's still so much headroom for us to I don't even think that we're using coding tools, code assistants as well as we could.
I completely agree. I think I underestimated, but I'm beginning to fully appreciate how important the prompting is. There are things you think these models can't do, but if you spend time on the prompt, you can eke it out.
Yeah. Do you want to hear two kind of funny tips that I have about using Cloud Code?
Absolutely.
So whenever I see you're absolutely right, or some bold claims about, hey, your app is now the top of the world, I do one of the two things. One, I would say, be honest. Review your change again. And then surprisingly, it will have an opposite answer. Or it will list like 20 mistakes and things to change.
I believe it.
So that's one trick. The other trick is I would say, well, my friend said this and this. And then Cloud Code won't agree with the same level of enthusiasm. So
there's a paper that came out of, I think it was Wharton School of Business recently, where they used a bunch of like social manipulation tactics to try to, basically jailbreak these models.
Yeah, we're just too mean to the models.
Well, it's shocking to me how much you can take proven methodologies to manipulate people and apply those to models, and it actually seems to work just because it was trained on a corpus of language data that was generated by humans.
That's
right?
exactly right. It makes perfect sense. I love it. All right. Well, this was fantastic, guys. I appreciate it.
Thanks for having us.
Thank you so much.
Thank you for listening to Hidden Layers. This series is hosted by Kung Fu AI, a management consulting and engineering firm focused exclusively on artificial intelligence. If you have any questions or thoughts about today's episode, or if you know someone we should feature, please visit us at kungfu.ai.